Okay, so we're going to do a quick rundown of the review. I'm just going to try to do this all in one go. Number one, you're just using V equals D over T. And so that would be 6.3 equals distance over 8.5 seconds. And multiply that together, and you should get 53.55. For number two, you're doing the same basic thing, except this time we're solving for time. So we have a velocity of 480 meters per second. And for A, we are going a distance of 200 meters. So we would do 480 equals 200 over t, which would give us 480t equals 200. And then divide it, and you would get t is equal to 0.417 seconds. For B, you got to get that into kilometers first, so that's 9,400 meters. So 480 is equal to 9,400 divided by t. And if you solve for that, the same way we solved for this one up here, you would get 19.6 seconds. Number three, let's see, you run 100 meters at a speed of 10 meters per second and then walk 100 meters at a speed of 1 meter per second. What is your average speed? So we need the total distance traveled, which we can find by doing 100, which we can find by doing 100 meters plus 100 meters and getting 200 meters. But then we need the total time, and we would do 100 divided by 10 to get the time for that first section. 100 meters divided by 10 meters per second plus 100 meters divided by 1 meter per second. And we would get 110 seconds. And then to find the average speed, you would just do 200 over 110, and you would get 1.82 meters per second. The one thing you cannot do not do this for finding average speed. If you want to find average speed, don't do 10 plus 1 divided by 2. This will not work, all right? Will not work. Number four, you're in a car going 60 miles per hour for 2 hours and then 30 miles per hour for another hour. What was the average speed? So again, total distance, total time. Total distance would be 60 miles per hour for 2 hours. That's 120 miles. And then plus 30 miles per hour for 1 hour. That's 30 miles for a total of 150. And then the total time would be equal to 150. Total time would be equal to 3 hours. So you would have a average velocity of 50 miles per hour. Okay. So if we go to the next one, number five, you're doing essentially what is this object doing? For A, it's moving at a constant speed. That's what I wanted for that. For B, what is the average speed? To find the average speed, you would just take the total distance over the total time, which would be 30 meters over 6 seconds, which would give you 5 meters per second. And then write an equation. When you write an equation, you're using y equals mx plus b, but we don't want to use those letters because we want to use the ones that are on the graph, which in this case is x equals 5. That's the slope. Because you found it up here. Notice that's the same thing as a slope, because if we take the point 30 and 6 and 0 and 0, we would get that slope. So again, if we use 30 comma 6, 6 comma 30 and 0 comma 0, we would get the 5 meter per second slope. And then rather than x, we're going to use t. So x equals 5t, and then the y-intercept there would be 0. Number 6. The image of a meter stick in a photo is 5 centimeters long. What is the scale factor? So this is like that softball we did, where the softball was 1.7 centimeters on paper and 8.7 centimeters, or 8.5 in reality. But essentially the way you would write this is 1 meter in real life was equal to 0.05 meters on paper. Okay? Number 7, during what time interval, 7a, what time interval was the object moving the fastest? It would be between 0 and 2. For B, you know this because it has the steepest slope, and if you calculate it, it's 10 meters per second. The other slope is 5 meters per second. Describe the motion in words from 2 to 6 seconds. It's at rest. C was describe what was the average speed for the entire 10 seconds. So to find average speed, again, do total distance over total time, which in this case would be 40 meters divided by 10 seconds, which would be 4 meters per second. D, describe the motion in words between 6 and 10 seconds. So 6 and 10 seconds, it would be going at a constant speed. And lastly, E, how fast was the object going when the clock was reading 8 seconds? So find the slope of the line of the graph at 8 seconds, and if you find the slope of the line of the graph at 8 seconds, you would get 5 meters per second. Be sure you, when you're doing that, use the points that are easy to find. So for instance, I'm going to use 6 and 20 and 10 and 40. Those are going to be my 2 points. And if I did this, you would get 40 minus 20 over 40 minus 20 over 10 minus 6, which would be 20 over 4, which would be 5 meters per second. Okay, on the back, you're looking at 2 ants racing across the top of a Wheaties box. So basically, there's 28.1 centimeters they're trying to get, and one is going at 4.2 meters per second, and one is going at 3.9 meters per second. And we're trying to figure out how far behind the second ant is. So what we're going to do is we're going to find the time it takes for the first ant to get there. So we're going to do 28.1. So actually, we're going to set this up. 4.2 equals 28.1 divided by t, and then t would be equal to 28.1 divided by 4.2. So if we do that, 28.1 divided by 4.2 is 6.7 or 6.69 seconds, and then we're going to see how far 3.9 got in that time. So d is equal to 3.9 times 6.69, and we see that one went a distance of 26.09 meters. And so we're just going to subtract that from 28.1 and see that it was 2.01 meters behind. Okay. Number 9, the bees racing. When you got the bees racing, the easiest thing to do is to set the distance for BA equal to the distance for BB to see when they catch each other. Or when B passes A, that's when he's going to catch up to him. So he catches up to him and then he passes him. So when these two are equal, that's when we're going to know that they've passed. So I'm going to keep 40 meters on A because he gets a head start. And then I'm going to figure out how far he would go, which would be 13.6 times t. And then I'm going to figure out how far B would go, which would be 15 times t. And then I'm going to solve for t. So 40 equals 1.4 t. 40 divided by 1.4 is 28.6 seconds. And so that's the answer to A. And then to answer B, how far would B have traveled? You're just going to do 15 times 28.6, which is 429 meters. 429 meters. And then lastly, number 10, essentially you just need a slope that's 2 meters per second. So one way to check this, just to make sure you did it right, I'm just going to do 1 point so that you can see it, 10 and 5. If it's 2 meters per second, you should have a spot there, and your line should just go up at a constant rate. The box below, the slope of this line is just going to be 2 meters per second, the speed, because it's a position versus time graph. The speed is the slope. And then the b value is going to be 0, because if he hasn't gone anywhere, then if he hasn't had any time pass, he hasn't gone anywhere. So the y-intercept is 0. Okay? All right, so this is a little rundown. Hopefully this helps. Good luck tomorrow.